Okay, hi all. So for now, I want to share with you about the idea of vectors and then how we could actually use vectors, and then just the basic concept of vectors. The meaning of vectors is actually, it's very related to, it's actually something about like a measure or something, but that it's mainly connected to two things. It has to be having a length or a magnitude, or some people said like later they go with distance, and it's also mainly talking about directions. So then some examples related to vectors are like force. Examples like force, like force can be like for example like 50 Newton to the right, for example. Right, so then that's the idea of vectors. The meaning is that it has a magnitude, it has a size, that's another name, a size, and then also the direction. But then because we're in math, we're talking about the abstraction, which is the generalization of the concept. So then we'll be talking more about the abstract part, like not talking about the force. Force is just like the application, but then we will look into the idea of the basic idea of it, the foundation. So then let me show you a couple of examples about how we represent vectors. So for example, I have like this. So this is one example of vectors. Let's say I name it A, B, because it's going from the A to B. So this is called the initial. This is like the final location. So then this vector is called vector AB. Then this is how we name it, AB with the arrow. Or in some cases, people also use, like, let's say we can also name it as the vector P. They usually in textbook they go bold. So then this AB is also equal with P. And the way we present vectors is that we use it like kind of like a gradient thing. So the way we represent or we write vectors is go like, because we know like 1, 2, 3 the distance, 3 to the right, and then 2 up. So then the way we write it, so you go 3 to the right and then 2 up, right? The shift right and then shift up and so on. So then this is how we write it, the way we represent. So then the number of the number 3 represents the horizontal motion or movement. The 2 represents the vertical motion. So another example, let me erase this part to give you an example. Another example is that I can draw, for example here, also 2, 3. So you see, even though this is also a 2, 3, even though the location is different, but then the vectors, because we're talking only about the direction and the size. The initial position does not really matter in that sense. So then we can say that, sorry, why is it 2, 3? It should be a 3, 2. My bad. It should be a 3, 2. So then, let's say I name it, this is PQ. So then in this sense, this vector PQ is actually the same with vector AB. The reason is because they are exactly the same. Exactly the same in terms of direction and magnitude, like the length. You see this, you can see that the length of the lines, they're actually exactly the same. So after this, I'll show you some more examples of vectors, like the equality, and then whether they are parallel, and then how we add up, and all go with the operations of vectors.